All right, here we are on activity 114, targeting success using data. And we're kind of down to the distance learning support option of this on question number 7. So we've taken the spreadsheet of the data that's been collected for the simulation of this activity. And now we're going to get ready to put those formulas in here. So on step 8, it says use the distance formula to calculate the distance of each landing location from the target. Well, so here is the measured distance. What we are going to do is we're going to just kind of pull that over there a little bit, and we're going to put another column in here called calculated distance. Now, how do we calculate the distance? Well, this is that a squared plus b squared equals c squared. This is the Pythagorean thing. So what we have here, and if you think about writing this out, we have what amounts to the square root. So I'm going to let the computer do that for me. So that's how I get the square root in there. Now I've opened up the parentheses. So it's the square root of what? Well, it's the square root of the x coordinates plus the square root of the y coordinates. All right, so I need to select the x coordinates and take that to the power of 2. All right, and then I need to add that to the y coordinates, also squared, little up caret 2. Now, to make sure that the math is done right, I'm going to go back in and add extra parentheses just to make sure that the spreadsheet does the math the way I want it to. All right. And so after all that, I hit OK. And I can guess that I did it right because my answer, the calculated one, came up very close to the measured one. Now, I need to copy that all the way down here. So I could hit the Control-C, Control-V button. I can go right-click and copy. I can go right-click and paste. And you can see that it's putting the numbers in there for me. But the quickest and easy way to do this is to grab that little blue box in the corner there and just drag her all the way down. Now, I can guess that my numbers and my formulas are right because I can go through here and check to see if there's any outliers, anything crazy going on. And it doesn't seem to be that way, just at a quick glance. Now, since there's only one decimal place here, I'm going to highlight this column and I'm going to decrease the decimal places down to 1 as well for this one. Now, do I have to do that? No, I just want these two to look similar. Okay. Now, if you look at the distance formula that I did up here, if I double click on that, you'll see that's in there. And if I look in the activity, it shows a similar formula. They just did it slightly different than I did. Okay, they took the -0 in there and the -0 in there because really, what is the initial x and what is the initial y? Well, all these measurements are based off of the origin. So theirs is probably better than mine, but I did kind of a half step of math in my head. All right, but we got it done all the same. Okay. So now that I have all of that done, I need to quantify my accuracy. I need to know how accurate is my machine at this point, okay, my launch device. Okay, so what it's asking us to do is to look here at step 10. We're not drawing the circle in person, so we're team 1. So you can see that here is a piece of data given to us, and this is step 10B to determine the measured distance. So now, what do I need to do? I need to figure out how far that is. Well, if I was in person, that would be easy. I would just measure that. But since we aren't in person, we're going to use the trig option of doing this. We're going to use the equation similar to what we just did, where we can see that, and it's going to be hard to see on the screen, I understand that, we're 5 units to the left and not quite 2.5 units up. And each one of these is a centimeter. So we're 5 by 2.2. All right. So if I put those down here below, I do 5 and I do 2.2, and then I do the math. Well, how am I going to do that math? Well, watch this. If I put these numbers in here as -5 and 2.2, I can copy this formula down one more block and I get my answer. Okay. Now, last time I did this, I went to 2 decimal places. Okay, so that's why you see a different number here. All right, so now we need to create a formula using this spreadsheet to mathematically determine the center of the launch landings. All right, so how are we going to find where the center actually is? Well, first, this was me just adding something to the spreadsheet, so I need to take that away. So in the activity, under number 11 there, it says finding the center. The mathematical center of the data can be represented as the point X with a line over it, Y with a line over it. Well, what does that line over it mean? Well, that means that's the mean, okay, or the average of the X's and the average of the Y's. So if I go back here to my spreadsheet, I can use it, let my spreadsheet do the work, equals, I'm going to type in average, and it suggests that I want A2 through A26, and that's right, I do. I want all of the data in column A. And if I do that again, it's going to give me all of the data in column B. So now that I've done that, where is the center really at? Or how accurate is my center? Well, that's the X and the Y, and the actual measured distance is how far I'm off. So originally, we thought we were off by about 5.5 centimeters by measuring it. And looking at the picture, we figured this was about the center of our data. Well, mathematically, I was more accurate, or my machine was more accurate, my device was more accurate, because mathematically I came up to just under 2 centimeters off. Now in step 13 here, it says compare the accuracy of your device to the accuracy of other teams. We're not going to be concerned about that at this point, but what we would have done is we would have had the other groups do data 2, 3, 4, and 5, and then we would compare them. We're not going to worry about that at this point. If you get those top ones done, you're going to be in good shape. Now, as we move on here, now we have to quantify the precision. All right, so it says use the circle you formed around your launch location data points to estimate the precision of your device by measuring the diameter of the circle. Well, what's the diameter of my circle? Where there's the center of it. And if I go over here, I'm at about the 19 centimeter side. So I've got 19 centimeters, and then I was 5 to the left. So 19 and 5 is 23, and that's my radius. So my diameter is going to be 46. And you can see that I put that right there. Not 46, 48. Hold up, better do my math in my head. Okay, so I got 19 plus 5 is 24. 24 times 2 is 48. All right. So when you don't write down your numbers, you don't show your calculations, you might screw up. So luckily for me, I had already done this ahead of time. Now, we have to calculate a target. All right. Well, if we go back to the criteria, they left a piece of criteria off here. If we go back to the original design brief, the first thing that said was, what is the target? And the target is no more than 3 to 5% of the data, or 3 to 5% of the launches. Then we have to figure out where our next bullseye circle is going to be, 25% of the targets. And then finally, add another 50%, so that'll be at 75%. So let's go back here to our spreadsheet, and we need to take these calculated distances. Remember, I'm going to take this bottom one off because that's really not in it. And I'm going to sort this data from lowest to highest number. So in other words, my most accurate launch to my least accurate by highlighting all of them. Clicking on data, sort range. Now, I say that it has a header row, meaning that the top row is the information about it. And I want to sort these by the calculated distance. And I want to go from A to Z, which is basically low to high. And you'll see what I've gotten. All right. So let's say 5%. There's 25 data points here. If I go 25 times 0.05, my target can be no more than one of those launches. So somewhere between 3.6 centimeters and 4.2 centimeters, I have to make a target. So I'm going to say that my grand prize target is going to have a size of 4 centimeters. Okay, so that's the size of my grand prize target. So when I start to go and make this, my grand prize target has to be no larger than 4 centimeters. Okay, now it says 25% of them need to land in the next inner bullseye. Oops, I forgot to put the equal sign in front of it. If I don't put equal sign in it, the spreadsheet doesn't know that I'm wanting to do a formula. So it's about a little over 6 data points. 1, 2, 3, 4, 5, 6. Okay. So if I go in that 6 to 7 range, see how there's like a 12.4 and a 13? Okay, if I drew a line right there, I would have my first 25% of my data. So I'm going to call this my inner bullseye. And I'm going to choose that 13 centimeter option, because that means that approximately 25% of my data is going to land in that first interquartile range. Okay, remember back when we did the activity at the very beginning of the year on interquartile range, and we had the first quartile, the second and third quartiles, and then finally our fourth quartile, or our box and whisker plots. That's where this is kind of using that information. Now, I'm going to use that same formula, except now I'm going to increase it to 75% times 25. So now I'm up to almost 19 places. Well, instead of counting these, I know that if I go down here to number 19, that's really my 18th data point. So between 18 and 19, so right in this region. So I'm looking here thinking that 18 or 19 inches, I'm just going to say it's 19, not inches, my bad, 19 centimeters is going to be my outer bullseye. Probably should call it the middle bullseye, middle circle. All right. And anything outside of that is going to be whatever's left. Okay. So that allows us to now say that if we made the circles or the targets or whatever we put on our carnival game, these sizes, that should mathematically prove that only 4%, 3 to 5% of the people are going to win that grand prize. Approximately 25% of the people are going to hit that inner bullseye. 75% are going to land in that middle ring, that middle circle. And then everybody else, the remaining 25%, are going to be outside that. So now, knowing what we know, we can make prize choices based on the data instead of just randomly selecting stuff. All right. So this allows us, what you're going to do now, take this information. You're going to take a screenshot of it, like I did right here. And I'm going to copy that. And I'm going to go back to my portfolio. And I'm going to replace the screenshot that I did earlier with this one. And I'm going to just shrink it up a little bit so it stays on one page, just kind of making it neater. There we go. And now I can go up here into my checklist and confidently say that I've done all of these things, including my final hole size and location. I can cross that off. Now all I have left to do is create my game rules and instructions, my carnival booth setup documentation, and then actually build my model, test it, and prepare my one paragraph proposal.